The next important theorem in probability is Bayes theorem. I am going to explain you the statement. That is, if an event A can occur only in the combination with any of the n mutually exclusive and exhaustive events E1, E2 and so on En, and if in an actual observation A is found to have occurred, then the probability that it was preceded by a particular event EI is given by the statement, that is probability of EI given A. That means already the values of A have been given, which is equals to probability of EI into probability of A given EI by sum of the numerator value. That means, see, here we are going to use the conditional probability definition and we are going to use the multiplication theorem. As the values of A are already occurred, we are going to explain about the events from E1, E2 and so on up to En. Now, what is meant by mutually exclusive events and what is meant by exhaustive events? We are having two definitions here. Mutually exclusive events means those the events which are said to be mutually exclusive. Happening of one event prevents happening of other event. For example, A wins the game. That means completely B loses the game. Now, what is the second definition we are going to use here? That is exhaustive events. Exhaustive events are here over, that is E1, E2 and so on still up to En. These are all the possible outcomes which you are having. Now going towards the proof. Consider the following Venn diagram. See, this is your Venn diagram where S is your sample space. I already told you E1, E2 and so on En are your exhaustive events. See, since E1, E2 and so on En are n exhaustive events. How you are going to get the sample space value S? By taking the union for all these events, that is E1 union, E2 union and so on still up to En union, where S is nothing but your sample space where you are going to write in a set, that is all the possible events. Those are E1, E2 and so on still up to En. And by taking that equation, the value of A, which is an event that can occur with any of the mutually exclusive and exhaustive events. That means, listen, that means we are going to tell that it is an mutually exclusive event. Now, therefore, A is equals to E1 intersection A union E2 intersection A and so on union En intersection A. If you are going to do intersection value for this, for events this and for this event, all these will be our mutually exclusive values, which we will be taking the intersection point with your A. Now, as we have already discussed about the axiomatic definition of probability, we are having three properties over there. The first one is of axiom of non-negativity, and the second one is axiom of certainty, and the third one is axiom of additivity. Here we are having union, that is E1 intersection A union and so on still up to En intersection A. Wherever the union is there, just we are going to write plus, that is addition symbol. After taking the probabilities on both sides, that is probability of A equal to probability of E1 intersection A plus probability of E2 intersection A and so on probability of En intersection A. As I already told you that all these values are mutually exclusive events, you may get that. See, probability of A is nothing but while we are going to add all these things means we are going to take directly some value, that is auto sum or a summation I is equal to 1 to n probability of ei intersection a. All these are added here. Just we are going to take the probability over there. And I already told you it is still up to I is equal to 1 to n. Now we are going to use the multiplication theorem. What is the multiplication theorem statement? Probability of A intersection B is equals to probability of A into probability of B given A. Like that, we are going to use that probability of A intersection A is equal to probability of A into probability of A given EI. Let it be taken as equation 1. I already wrote here, that is since from multiplication theorem. And the conditional probability of an event EI given that A has already occurred is probability of EI given A. How we are going to write? Again we are using the multiplication theorem of probability, that is probability of EI given A is equal to probability of EI intersection A by P of A. Or in the place of EI you can take B, in the place of A only A. Then you will be getting your multiplication theorem of probability. Now, as you already know about this, probability of EI intersection A is nothing but you are using the multiplication theorem of probability, that is probability of EI into probability of A given EI by P of A. Let it be taken as equation 2 since we are using the multiplication theorem in the numerator, as the values of A has already occurred. That means EI given A. In the last step, we are going to use the last step, that is probability of EI from the equations 1 and 2. Probability of EI given A is equal to, in the numerator is same, and in the denominator what you are having? Probability of A. As in the equation 1 we have already written that probability of A as summation I is equal to 1 to n probability of EI into probability of A given EI. Hence we have proved our Bayes theorem also. Thank you.